In this short video, we'll be discussing how to perform a running fix, which is something you might need to do if you are navigating on a boat. So a running fix is used when only one object on the shore is visible to use as a marker. So we'll have a look at the following example. A vessel is at point P and has been travelling at 10 knots. So this P represents a boat at a given time and it's travelling at 10 knots. The intended course is 0 degrees true. 0 degrees true is directly north, so this line represents the intended course. The bearing of the shore object O is taken at 0900 hours, which is 9 o'clock in the morning, 9 a.m. So this is the bearing of the shore object from the boat. Now notice we're not told the angle, the true bearing, anything. We're just told that the bearing is taken. So it's assumed that the captain knows what that bearing is, but the line is drawn in for us. And then 36 minutes later at 9:36 in the morning, the bearing of the shore object is taken again and is found to be 270 degrees true. So this is the process we go through in order to perform our running fix. Firstly, starting with that final sentence, at 9:36 the bearing of the shore object from the boat is 270 degrees true. That is directly west, because if you measure around 270 degrees from north in a clockwise direction, then you are facing west. So that is the bearing of the shore object from the boat. Next, we have to find out how far we've travelled in that 36 minutes. So we've gone 36 minutes, which is 0.6 of an hour, at 10 knots. 0.6 times 10 gives us 6 nautical miles. And so then, to find 6 nautical miles, we measure along the line of travel using the latitude scale. So 6 nautical miles using the latitude scale is 6 minutes. Each minute represents 1 nautical mile. So that black line there represents 6 nautical miles. And then we just draw that onto our line of travel. Now, normally, if you were doing this, you'd think, hang on, but I already know where I got to because I was heading north, I intersect with that line. That must be where the boat is at 9:36. But unfortunately, this point P was a bit of a guess. So we didn't actually end up here. So we went 6 nautical miles. We haven't quite gone far enough to get us to this line, which gives us a bearing of 270 degrees to the shore object. So then what we do is we draw a line parallel with the original bearing. This is the original bearing. And it passes through the top of my 6 nautical mile line. So we'll call that point Q. And then we draw a line through point Q parallel with our direction of travel. That line there is actually our direction of travel. So this is what happened. At the start, we had a little bit of a guess. We said, look, this is our bearing to the shore object. I'm heading north. I think I'm about here. So point P, the original point that we mark on our diagram, is a bit of a guess of where we are. We know we're heading north. We know we're somewhere along this line because this bearing is accurate, but we don't know where. So we have a bit of a guess at P. Then we have to perform our running fix and draw in our extra lines, and we actually find out that we weren't at P when we started. We're at this point. So what happened was we were here. We headed north for 6 nautical miles, which makes sense. We know this length is 6 nautical miles, and we've reached this point, which gives us a bearing of 270 degrees true to point O. Now, we're going to have a little bit of a look at why that works. So the reason this works is because in this diagram, we've created a parallelogram. So see if you can see a parallelogram here. These 2 black lines are parallel, and this small line here and this small line here are parallel. So we've created a parallelogram. Now, in any parallelogram, we know a few things. Firstly, a parallelogram is like a rectangle that's being pushed over. So AB is the same length as DC, and we also know that AD is the same length as BC. So this is what we've done here. We've created a parallelogram where this 6 nautical mile line is parallel with this line, and this line here, our original bearing to the shore object, is parallel with this line. So that's why we introduced this vertical line, this parallel line here. So we've created a parallelogram, therefore we know if this is 6 nautical miles, then this must also be 6 nautical miles. And this is our final position at 9:36.